Welcome. In this video, we are going to look at multiplying and dividing complex numbers. And this is just a property we can use when we have two complex numbers that are given in trig form. So given in the form of r times the quantity cosine theta plus I sine theta. And I just have these subscripts here. This says this is the trig form complex number 1, and this is the complex number 2. That's why they have subscripts 2, just to keep them together. So if we are asked to find the product, that would be multiplying the r values and then adding the theta values for each argument. And the quotient would be very similar. We would divide the r values and then subtract those theta argument values. So make sure you have these two definitions written down on your paper, because these are things you may need to know how to apply. And then let's do an example. Here we have the product of two complex numbers in standard notation. And sure, we can just FOIL these, but we are right now showing that we can use these properties in trig notation as well. So we're going to convert them to trig notation first, and then we'll multiply. So this first one here, 1 plus I, converting that into trig notation, I have that A is 1 and B is 1. So that means that R is the square root of A squared plus B squared, 1 squared plus 1 squared, or R is root 2. And then we have cosine theta is 1 over root 2. Sine theta is 1 over root 2. If I were to rationalize each of those, that would give me cosine theta is root 2 over 2, and sine theta is root 2 over 2. So hopefully you should be able to tell that this means that theta is at 45 degrees, or pi over 4. That means 1 plus I, written in trig notation, that's the same as writing root 2 times cosine 45 plus I sine 45. Similarly, and we did this one in a previous video, the video which was right before this, I'm going to go ahead and write my work out. So this work we did in the video right before this, we found that R was 2 and theta was 330. So we're finding the product here. Now, considering this notation, we're going to multiply the r's and add the thetas, and that's going to give us this product. So multiplying those r values, that's going to give me 2 root 2, and then I'll have cosine of 45 plus negative 30, or minus 30, plus I, and then we're going to have sine of that same value, 45 plus negative 30, or minus 30. And that is going to, of course, give us 2 root 2 cosine of 15 plus I sine of 15. So why wouldn't I have just multiplied these and then converted them into trig notation? Well, do I know how to get 15 easily off of the unit circle? I don't. It would be a little bit harder for us to deal with. Or perhaps we were already dealing with numbers in trig form, and this is a very convenient way to multiply them. So we multiply those r values, and then we add our theta values. Similarly, if we were asked to divide, so I'm going to list this here, and we'll say divide 1 plus I over root 3 minus I. Well, that's dividing these two values, or these two trig notation functions. we're going to have root 2 times cosine of 45 plus I sine of 45 over 2 cosine of negative 30 plus I sine of negative 30. So by the property up here, coming back up, if we need to find the quotient, we're going to divide the r's and subtract the argument thetas. So this quotient would be square root of 2 over 2. 45 minus negative 30, that's cosine of 75 plus I sine of 75. And that would be the quotient. The main purpose of this video was just to see how we could apply our quotient and product rules for complex numbers in trigonometric form. As always, email me with any comments, questions, concerns. Don't forget to like and subscribe. I'm trying to become YouTube famous. Just kidding, all my videos are unlisted. Maybe one day I'll be brave and share them with the world, but not today. Good luck. Email me.